Welcome to Edupedia Word videos. In this video, we'll be studying Pythagoras Theorem. The theorem says, in a right triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. So, to understand this theorem, let us first construct a right triangle. Let PQR be a right triangle, right angled at Q. That is, in triangle PQR, angle Q is 90 degree. So according to this theorem, the square of the hypotenuse. Now friends, hypotenuse is the side opposite to the right angle. Therefore, PR is hypotenuse. One of these two sides can be used as base and the other side as perpendicular. So, according to this theorem, the square of the hypotenuse, that is PR square, is equal to the sum of the square of the other two sides, that is PQ square and QR square. Let us have a brief proof of this theorem. For proof, we need construction. That is, construct a perpendicular QD on PR. Now since QD is perpendicular to PR, these two angles will be 90 degree. Now we need PQ square, that is this side square, and QR square and PR square. Now consider two triangles, this smaller triangle PDQ and the complete triangle PQR. We have taken the order of PQR in this form because P is the vertex common to both and the angle P is same, and D is 90 degree whereas Q is 90 degree. So D will be corresponding to Q. Now in this triangle, angle P is common in both the triangles, and angle D of this triangle is equal to angle Q because both are 90 degree. Therefore we can say that triangle PDQ is similar to triangle PQR by AA similarity criteria. Now since the triangles are similar, we can say that the ratio of the corresponding sides will be equal. That is, PD over PQ from this triangle will be equal to the side PQ and the side PR of this triangle. This will give us, on cross multiplication, PD into PR is equal to PQ into PQ, which is PQ whole square. Let this be equation 1. Now consider the second half triangle, that is in triangle RDQ and triangle. Now we will take the complete triangle, but let us inspect the order in which we have to take. The triangle is PQR, no doubt, but this R vertex of first triangle will be corresponding to R vertex of this complete triangle. Therefore first vertex is taken as R. Now for D, which is 90 degree, Q will be the corresponding vertex and the remaining vertex is P. Now in both the triangles, angle R is equal to angle R, that is common to both, and angle D is equal to angle Q, which is 90 degree in both the cases. So by double A criteria, we can say that RDQ is similar to triangle RQP. Since both the triangles are similar, we can say that the corresponding side, their ratios will be proportional. That is RD over RQ is equal to RQ over RP. On cross multiplication, we have RD into RP is equal to RQ whole square. Let this be equation 2. Now friends, for proving this theorem, we need PQ square plus QR square on one side. Here we have PQ square and here RQ square, which can be rearranged as QR square, because RQ or QR are both the same length, the same sides. So if we add up the right hand sides of the two terms, we will get right hand side of the required equation. Thus we can add both the two equations 1 and 2, that is adding equation 1 and equation 2. We get PD into PR plus the left hand side, which is RD into RP, is equal to PQ square on the right hand side and QR square on rearranging the right hand side of equation 2. Now friends, PR and RP are both the same length, so these two can be considered as the same length PR. Thus we can take PR common from both the terms, so we are left with PD plus RD equal to PQ square plus QR square. Now friends, PD is this side and RD is this side, so we can say that PD plus RD is equal to the complete side PR. So on substituting this 3, in this equation, we will get PR into PR is equal to PQ square plus QR square, or we can say PR square is equal to PQ square plus QR square, which is the required original equation. Hence, this was the proof of Pythagoras theorem. Thanks friends for watching this video.